So this next step is definitely a bit intimidating. I don't like having to touch this again, but I don't think it was fully ready to be put into use, and now we're going to try to do it. So we're going to try to. I was discussing this in the video following up to this. I'm going to try it right now. The way I structure this system is I define these enums that are sort of open enums that you can add codes to them from anywhere else in the code. And they get compiled together and associated to some other metadata that you can bind at the declaration site through this registration system. What the register stuff does is it lets me run a function ahead of time before the main program starts, and that function just grabs one of these data and remembers what we got to do with it. Ultimately, this kind could be implied by the location of the data instead of by marking it. We could gather together an array of just the data that we need, and this then needs to know its display name and the function pointer. If they are sorted out correctly, the ID will be implicit because it'll also be figured out from location. So really all we should need here is something like this. Well, what if we just did tile protos? Okay, what I'm going to do is I'm not going to rely on the ID system anymore for this one. I'm just going to do it out manually. Got to deconstruct it for a little bit here. This is RPGTL. Read. Right. Here is just RPG tile enum. Save an ID enum called RPG tile enum like this. then it would just be this. You define a tile by actually giving some values to the literal at the global level. Okay, and then instead of an init, so reg data kind tile isn't even going to exist. And instead what's going to happen see, this does address minus bias divided by tile proto gives an ID. So later what I think I want to do is this gets replaced with symbol hackery that turns each of these into into small consecutive IDs, and so these become the same thing. There's no way to actually ask for the pointer to any of these through its symbol name, or if there is, we do it by having separate symbol names for each one that need to resolve to different places or something, but it would always be indirect anyways. The more important point is that you need some way to be able to go where's the base of the array and the count, and that's what this is doing now. This is a count, this is a base. We might be able to turn these into symbols that get filled in as well. So let's proceed like this. Tile proto count, tile enum.count, tile protos equals RPG tile proto pointer putter from int RPG tile enum.bias. So we might rename that to base or something like that. There are none of these, none of these. We're just gonna loop over the tile proto count. At each step, the tile ID is just gonna be I+1. The RPG tile proto is just gonna be tile protos plus I. You don't need a tile ID. You don't need reg data. Proto init from reg data doesn't mean anything anymore. It's just going to be init tile proto init. Doesn't take a reg data. Now the hook and the name are already determined. By the initialization, it's just everything else that we're gonna fill in. Then we save the name. Okay, so there we go. There we go, everything's working. So, I think that's more the right speed. I think everything here needs to be redefined in those terms. There won't be gather and magic ID. Let's see here. ID.def.h, what we're going to add, or how we're going to rearrange things is we're going to go with this we're going to go with this notion. That we're doing, this is this piece, that sets up the enum. This is this piece, that's good. This is this piece. Range comes in here, then we do range.opal minus range.first divided by size of ID metadata type or something like that. Right, so then this goes ID data type, RPG tile proto to get that in there. This comes int from putter first, and then we go undef ID data type. Include Mr. Forth ID def.h. Now that's almost gonna work, except I have to go tell all of these about how they're actually like this now. Later we're gonna undo these. Okay, here's another one of these. And that's different. Okay. And so each enum still has one before main, which just sits there to get the bias and count correct. And we still count on getting those done before you can resolve IDs properly. But does everything else work? No, something's off. Okay. What happened? Tile, proto, heart, hook, regs. Tile, regs looks fine. Well, what's the issue? Oh, is it that, yeah, this needs write permission. There we go. Back to working again. So, 0, 1, that's an unusual end state. How is that possible? They went into... Oh, it's all off. It's all off. All right, so let me double check that these are defined correctly now, since we're relying on them. Def is correct as a default, although that's not guaranteed to be correct when this is a struct instead of a U8. Okay, I think we need to do, instead of ID type name, I'm gonna need to do something more like there we go. But the IDs are still off. And that's because id.h need to be going ID type E. section name, ID type. Oh, it shouldn't be section name, that should be type. Okay. Whoa. How did that get so far without getting caught, though? That doesn't make any sense. Well, that's not good. That shouldn't also be a 1. ID reference event enums U8. This used and tile header are definitely big and different. ID def dot h takes event enum type right here. Looks good to me. So why would it be ID RPG event enum this decremented looks like this. RPG and then there's U8 RPG event enum dot bias. Right, so this should be coming out as like 6, right? Yet somehow that event code says 1. ID ref, ID.h, ID ref is, oh, it shouldn't be divided by count, it should be divided by the size of ID type E. Okay, now it's infinite looping. How is that happening? First of all, if we come in here, we are at least getting, yeah, a good event code. That doesn't do anything. Come out. Style proto has all its state set up, and there we go. Now, where are we getting stuck? Oh. This is super bogusy. What am I missing? Is this like indent? We writing out 2 spaces of indent? Is that the point? Okay. We get the last node. Look at our stream. If node equals 0, it doesn't. If we didn't get a buffer. We did. The buffer is node data plus the node size. The buffer size is 0. Node equals last node. Buffer cap. Something went wrong with this stream writing for sure. There's just a bug in it somewhere for sure. Somehow it's getting to a state where it has a last node and a buffer cap greater than 0. I think we have to, if the buffer is full, forget this node. If stream buffer, if node does not equal 0 and the buffer cap less than or equal to the node size, then node equals 0. I think that might be the whole problem. Maybe we just filled up the node, so the buffer size was coming out to 0, and we weren't making progress with the copy. Of course, it still seems like we're infinite looping. We just might be infinite looping there because it's a bug I haven't hit before, but now that I fixed that one, maybe I can see us infinite looping. There we go. So we go find a rule, go. And I imagine we'll also be finding rules like this one. Some of the time. We just keep ending up back at fight. We don't go to combat round at all. Okay, how does this happen? So we have 7 characters. That hasn't changed. We've got 0 attacks, 0 late attacks, 16 quick actions, and 0 actions. So they're all taking quick actions? Only? What are their quick actions? What are they doing? Shuffle and run moves. Ba-da-da-da-da-dum. Get to the character. Interestingly, this counter has an amount of 0. Did you do this? Okay, so this looks basically like it should be working. Wait, some of them already have. The tile to. Okay. Well, at least they should all have one of each, right? So now that's good. We're gonna come in here. Increment by 1. Two, 3, 4, and these ones already have one, so we just keep it. 3. So everyone should have actions. Decision, pick, subset. We do that. For whatever reason, we don't pick any attacks, late attacks, quick actions, and actions. I might need to go and check out why that's happening too, but I'm still confused how it is that we get this far. And our characters. Come in here. And then they fail this if 3, 4, 5, 6, all of them fail. Even though just a minute ago we set a bunch of them to 1. So the question is, are they all asleep? How is this happening that they are all getting 0s by this point for their quick action count when we just set all of them to 1 here, and then this shouldn't be modifying them? This could be modifying them, but that would only be possible if they're all asleep. Okay, first moment we fight, we grant moves to everybody. Round begin, tile hook, Run proto. Hook. Heart does nothing. Yeah. But some of you are gonna be asleep. Oh. That's the gather moves hook. I meant to look at the round begin rule. Okay, so just count 1, 2, 3, 4 times we gather moves. 1, 2, 3, 4 times we clear the counters. But 3 of you still have moves. Now we come in here, we look at a character. Say we want to do that move. Of course, we don't have any moves, so because with this character, the person doing this is asleep. I guess. Okay, I think I have a guess about what might have changed. Let me just double check something. I didn't change the script for sleep yet, did I? No, this still only grants moves to allies. And it still targets a random ally when you do it. If someone runs wake up, I want to see. If someone runs, it could be attack. Maybe, it was working just before I changed this. The part that's weird is it kind of seems like what broke wasn't the logic of the scripts, but the engine somewhere. But it's a little bit of a strange way for things to break when it's the engine, so I'm not quite sure where to look yet. Fight. Round begin. 2, 3, 4. So that clears out all of the actions for the player party. Then we go on to decide on our moves. Here we are in fight. 2, 3, 4. Okay, no one ever uses any of the moves. That was one character, and they used wake up 4 times, and nothing else. Tile ID 6. Wake up. Tile ID 6. Are all of the character moves using the same tile ID or something? Tile ID 6, tile ID 6, tile ID 6. Why didn't we get any of the other possible moves? What happened to the other part of gather moves? Is that what busted? Let's take a look. Gather moves. we arrive at a tile if our parent is a character and the counter is greater than 0. And the tile can be used. So is that failing every time? Is that the issue? So we're getting the flee code, which is 5 passed in, but the actual state is 3, which is combat round. Except it's not, it's fight. So it's still off by 1 some of the time. Why would that be? Maybe id.h now has the right rule here, but maybe there are other occurrences of dot bias that I haven't corrected. Right, so to do these, what you have to do is go There we go. Okay, that's a pretty good proof of concept that this way of doing things could work. I think I'm gonna wrap it up here. because did a long first part of the stream. It's Friday, so getting done a little early feels nice, and then I can unwind. And there's still so much to do that I think I'm saving up the rest of this for next week, right? But like, let's see here. We took 3 damage, and 2 of us are awake. Then we got everyone awake, and we did 2 damage. Now it's 6 versus 4, 4 versus 2, and then 3 left. Yep, that all seems to work like it should. I want to up the odds here. Game, combat, default brain. Yeah, I've turned it off. Let's turn back on the odds of PRNG, roll bounded, context PRNG, 4. Let's do a 1 in 4 chance. Oh man, they both did it. Party 1 generated the speed. And so they were chasing, so fighting happened. Because apparently the sleepers tried to run away. Which obviously doesn't sound right and has to be modified, but just for funsies, another thing I can do here. You can make the sleeper party half sleepers and half farmers, but always run away. Why didn't they wake up everybody? Maybe they're not using it every time. I'm not sure. I'm not sure what their logic is, but they should. Oh, you know, when they have to run, they can't run and wake up, so they might there might be order dependence there on which decision they make, because they're both quick actions. Yeah, man, the running game is not meant to be easy. Okay, well, anyway, I think this is a good spot to stop. Let me go look at what we have. So I've explored this possibility. I'm convinced this is the right way to do things. So the new to do here is And then another big thing that's still just lurking around here is I really need to do clean up the map data structures. I don't know where the map data structure. Yeah, okay. This might end up meaning that I'm going to eliminate registry altogether. Okay. I think that's a good stopping spot for the week. So with that, thanks for coming and hanging out. If you've been following what I'm doing, good to have people around. And I will see you all around the internet next week. Bye.